So thanks everyone who's joining. Today we are taking a look at Azure Cache for Redis. So we will look at how to follow the patterns and best practices applying Azure Redis Cache to your .NET web app, and we'll have a demo for it. We will also look into how Microsoft has worked with the open sources communities in projects such as Stack Exchange.Redis to improve the overall developer experience. And then we'll look into how Redis Enterprise offers various capabilities to enable the integration with machine learning and AI projects such as OpenAI. So what is Azure Redis Cache? Well, Redis is an open source project. It's essentially an in-memory key-value NoSQL database store, and the nature of it makes it very suitable for being a data cache, alongside with a few other scenarios. Azure Cache for Redis is developed in partnership with Redis Inc. It is first-party hosted, fully managed, so developers don't have to worry about the operational overheads. Everyone can just focus on business logics when coding with Redis Cache. A few highlights for using Azure Cache for Redis. It makes your app performant and scalable. It's very cost-effective when working along with database. It has the network integrations to ensure everything is secure. And it integrates seamlessly with other Azure services if you host your entire solution in Azure. Now, you may wonder, where do I get started using Azure Cache for Redis? So if you go to Azure portal, say create a resource, and search for Azure Cache Redis Cache. You will see the first two images, Azure Cache for Redis Enterprise and Azure Cache for Redis. This is the second one is the community version hosted for the basic and premium tiers. So we always recommend starting with Enterprise for a bunch of advantages that we will talk about later. But even if you start with the second image, you can still choose Enterprise when you set the SKU for it. So after we create an Azure Redis Cache instance in Azure, what can we do with it? Well, there are a few scenarios. The most common one, we would use Redis Cache as the distributed cache alongside with your application to accelerate the data performance. For example, a well-known pattern is the cache asset pattern for your applications to always try reading from the cache first before accessing to database. And then the key value in-memory nature makes it a very fast data store. We usually put web application session data in cache. Also for other types of data like shopping cart, which does not have to be persisted all the times. Putting it in cache is a very effective way to do it. And then extending the data store scenario, Redis Cache is very fast for data stream processing. So for the real-time analytical type of applications like fraud detection, stock market, and IoT, Redis is a very good choice for storing those data. And finally, Redis can also be used as a message broker. So in cloud-native applications, if you have one microservice talking to the data store backend, usually use a pub/sub pattern to have a message queue for communication. And Redis does a very good job with that. So for all these scenarios, we may wonder, like, do we have to start from scratch when we implement all these? The answer is no. So we recently shipped the reliable web patterns for .NET. It's basically a collection of patterns and the best practices, uses various Azure services to implement efficient data access, well-designed data structures, together with security, performance, monitoring guidances. And there are small components and assets you can reuse. So in the overall guidance, you see Azure Cache for Redis here. It's used alongside with SQL for the cache set map pattern. So that is what we should always consider when designing our web applications. So let's zoom in to take a look at the demo using cache with the web applications. So I'll start with a web app talking to SQL, and then let's see how to transform it by adding cache to it. But here I have a small e-commerce application. It basically shows different products that you can view or purchase. Right now, everything's loaded directly from the database. While browsing through the items, maybe I want to take a look at the detail and then decide to shop later, in which case this item will be bubbled up on top of the page for me to conveniently add to cart if I make a purchase decision. And I can add various items. Now, if I go to my shopping cart, I see the items all added here. I'm not logged in yet, so maybe I'm a member of the site earlier, and maybe I have other items also in the shopping cart. So I can log in now. So after logging in, I see the previous items are already transferred to my logged in account. So now I can decide to continue shopping or simply check out. Now, since this web app is talking to database directly, for now it's fine. I'm just a single user. But what would happen if we have a lot of load put on the web app? Like, will it still be scalable? What are the potential problems? So right now, all the data information like products, shopping cart, and identity are all in SQL Server. This is fine for now, but as my application starts to receive a lot more traffic, this may not be scalable. And then for session data, everything currently is stored in memory in the web app server. Potential problems are in-memory session data would require sticky session to be configured, which means each client, once it established a connection to a server node, that server node stays with the client throughout the session. In the case of failover or scale out, data might be lost, which is not good for resilient and app maintenance. In addition, memory is a scarce resource, and we really want to have some control on how much of it is used before we start to get out of memory errors. That's why we're adding Redis Cache into this overall topology. So now we can cache the product's information in Redis Cache for fast access. We can move the entire shopping cart data into Redis Cache. Because when people were shopping, they can make decisions on adding new items, editing items, or even maybe they put a bunch of things in the shopping cart and then they decide to come back later. So there's really no point to persist this data until they decide to check out. And for session data, we'll also store it in the Redis Cache outside of the web server for app resiliency reasons. And in the database, we will still have copies of the products data and the identity. So you may wonder, like, the second topology looks very different from the first one. Like, do I have to recode everything? It's like almost like starting a new project from scratch. Well, the answer is no. you can actually reuse a lot of code from the previous topology. So this is my web app project, and this is the program.cs file where we configure the web host startup. Redis Cache can easily be added as a distributed cache service by the web app host builder. I just have to add one NuGet package, microsoft.extensions.caching.stack exchange Redis. I made sure it is the latest version. And then with simple configurations like get the connection to Redis, I can establish this service connection. Following that, .NET has default session services and is designed to work with any choice of distributed cache added to the host startup process. So I don't have to do any additional code or configuration for the session to know there's a Redis cache added to the app and start to store things in it. So as you see earlier, I was using memory cache. Now I decided to use Redis cache. I could just comment out the previous line and exchange it with the distributed cache service. And thanks to the dependencies injection pattern, for my cart service and the product service, I can simply switch the implementations to use cache for data access. And here I can leverage the dependency injection to choose which implementation of the interfaces I will use for my web app. So after all this, I didn't really have to change anything for my web app to pick up cache and start using it to improve the performance. And another feature I really liked is the distributed cache tag. It's very common to embed C# code within the Razor web app. So the distributed cache tag allows me to save any information as the output from my C# code into the configured cache directly. I can configure properties for the data information, such as like how long do I want to persist it, or as cache attributes, the tag attributes here. So after all these changes, how my web app looks like now. So this is the cache version of my web app. I can still browse different items and see the items I just viewed will be pop up here. This is the time management feature I built with the distributed cache tag, so customers can know when their shopping session started, and that helps them make a decision if to make a purchase or not. And then everything else stays the same. So when I add items to cart, now it writes directly to cache, which feels much faster than earlier. And all the shopping cart related operations are much faster. But I'm just one single user here. So how will this work under load? I did an experiment with the Azure load testing service. It's a recently released load testing service available in Azure portal, good for running quick load test by sending traffic to a URL, as well as integrations with the JMeter test. Like you can upload the test script for more complicated load testing scenarios. So I just ran a quick load test on my homepage with 1,000 users for 5 minutes. My throughput with cache was 459 requests per second, and without cache was 180 requests per second. So we can see by adding cache, just the read operation is having like more than 2 times improvement. So in the earlier demo, we talked about the Stack Exchange Redis. this is the library we built the distributed cache service providers implementation on top of it. And also for advanced user scenarios, for example, if you want to batch multiple calls to Redis Cache and you want to reduce the network latency, this is very good for like grouping those calls together and just make one single request to make your app even faster. So if you are advanced developers looking for like making your web app super optimized, you can use Stack Exchange.Redis directly in your app. So this library is developed by Stack Exchange open source. It was designed for busy sites like Stack Overflow. Microsoft has been collaborating with Stack Exchange.Redis maintainers to enhance the .NET developer experience with Redis Cache. And over the past years, we collaborated and worked on quite a few features to improve the reliability, application resiliency, and extensibilities. So let's take a look at the details for these features we together collaborated on. The first one, command queuing. This is to improve the reliability and the transient error handling in your app. Basically, this means in the case of a Redis client connection failure, if there are commands just about to be sent out, we will queue it in a buffer. So when the client connection restores, these commands will be sent out. So without this, if the commands were to be sent out and there's a client crash, the command will just be throwing failures, and developers will have to write code to handle the retry logics and error handling and so on. So with this feature, developers can further just focus on the business logic without having to worry about the connections, the clients, and so on. The second one, automatic topology update. This means the Redis client actually will maintain a real-time topology on where the shards of the data is stored, which primary or secondary node to read on. So this improves the success rate and further boosts the performance for real-time distributed cloud applications. This feature right now is optimized for Azure Redis Cache because we did something in the hosting platform in Azure, but it's adaptable by other vendors. As long as you send some message when topology changes on your server side, and the Redis client can subscribe to a channel and respond to it. And then extensibility. This enables customizations and help establishing standard for how Redis client configurations will be set. So for example, you can define the connections to be always SSL enabled, which is a good policy enforced for compliance reasons. Microsoft created the extensibility features, so we could work on the Azure flavor of the client, azure.stackexchange.redis, which is coming very soon. And then one last thing I wish to mention is please remember it's very important to keep your Redis Stack Exchange.Redis client up to date. And in the earlier demo, we also saw in the topology, there's the web app connected to Redis Cache and also to the SQL database. The entire environment was secured by Azure networking. And developers may wonder, what it takes to provision this whole environment. So we are shipping a feature in Azure Portal to enable one-click provisioning such an environment. It will be an option on top of the current web app plus databases template. You can choose to provision the environment in Azure Portal directly, or download a template for infrastructure as code. This is also coming very soon. So in the topology, we have one cache and one database, both are storing data. How do we keep the data consistency? There are 3 caching strategies. The first one, cache invalidating. This means every time a change made to the data store, like the persistent data store, we will remove the corresponding cache entry. So this would force the application to read the new data from database next time. And then we can put the new value in cache for future access. This is a very reliable strategy, but the shortcoming is it might be a little bit inefficient to always delete cache and read from database again and then update it. So the next 2 strategies, the write through and the write behind, would both update cache directly and rely on cache to update the data store behind it. Write through means the update happens synchronously, and write behind means happens asynchronously, which would allow even like a greater scale. Now the question is, how can we make sure the cache can update the data store reliably? Like what happens if the client update to cache succeed, but the cache to data store fails, and so on. So in order to make sure the cache and the database stays in sync, we are shipping another feature for Azure Function integration. This is exactly what we needed for the write behind and what write through cache scenarios, where an Azure function can be triggered by things in cache, and then corresponding to that, do a write or some additional data processing in the SQL Server. So beyond the consistency story, even for event-based architecture, like in IoT scenarios, millions of devices sending data to cache, we can have an Azure function there too to do the data processing. So that will be helpful in this scenario too. So cache can be having multiple nodes as well, and can be distributed across multiple geolocations. How do we keep each node of cache consistent? That's where Redis Enterprise comes into play. We have the active-active distribution. It has local latency, seamless conflict resolution, and uninterrupted downtimes to make sure like the node in different geolocations can also keep consistent with each other. So without this feature, you may have to do something in your application logic code to keep the consistency happening, or do extra configuration on your infrastructures. With Redis Enterprise, this all comes in as part of the product. It also has unparalleled SLA 5.9. This is like really valuable for cloud hosted services. It means like almost no downtime within 1 year using the service, and brings your application really up to enterprise scale. And it offers the zone redundancy to create cache copies in separate availability zones that can be failed over to in case of an outage. That's a further guarantee to make sure your app is always available to your customers. And it offers extended scenarios with rich data extensions. So there are a few extensions, Redis Bloom for probabilistic data. Redis time series is good for like real-time data processing IoT scenarios. Redis search for the searching, querying, index analytical applications, and Redis JSON for storing entire JSON document, or like full or partial querying, updating to it. Those are really helpful with the big data scenarios, real-time applications, analytical scenarios, and so on. So this all sounds very theoretical. Let's take a look at an example for how these analytical features can be applied in the AI and the machine learning scenarios. So vector similarity search is one feature with the Redis search data extension. Maybe we should firstly talk about like the overall story. So there are times in the AI machine learning scenarios where we may want to compare how two pictures are similar or different from each other, or going through a bunch of unstructured text as the feedback data, for example, and we want to draw some insights by grouping all these feedback data. Or maybe it's audio streams, and we just want to compare like what are the anomalies in the audios. So all this, how do we like compare those type of input? That's what embeddings come into play. It's essentially a vector of floating point numbers. You can think of it as a numbers representation of the previous input content types, like images, long text input, audios, and so on. So we have like engines like OpenAI available to transform the input into the embeddings. So now we have a like numbers representation of input from like various sources, various types. Now, with all these embeddings, it will become easier to compare the similarities and differences. So here's an example from the OpenAI website where we are using the text input from product review data. And then figure 2 shows examples of embeddings. It's like literally a vector of floating numbers. And with this numbers representation, we can plot it on graphs. And now it's like, if two dots are close to each other, they are very similar. If they are far away, they are different. And then we can leverage some other capabilities to compare like how different or what are the anomalies and so on. But we need rich query interfaces on top of all these like embeddings, right? So that's where the vector similarity search in Redis search comes into play. It has very rich analytics querying capabilities to compare like similarity, ranking, anomaly detections, and so on. And Redis as a very fast data store is also good for storing these embeddings, especially for the unstructured data like images, audios, long piece of text, and so on. And if you want to try it out with the Redis search, we have a .NET client library available. It's a flavor of the Stack Exchange.Redis called Redis Stack, available on NuGet. You can download and take a look. And we have a GitHub reference for how the demo works. So we have the references if you want to take a detailed look into the points we talked about.
Awesome. Yeah, I want to just pull up this one question before we move on to Mike's session. But we wanted to know if we could see the code for the example that you gave. So I believe that it will be shared soon, but can you give us more information on that?
Yes. So see the demo app on the in the reference list. That is the demo we were just seeing.
Awesome. And we will put that link in the chat here in a minute so that you can all link to it. Thank you so much, Catherine. This was awesome.
Thank you.